Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Yeah, okay, sure. So I'll just start. So, yes, it's great to have Susan here to talk to us. She's just coming to the end of her PhD at Portland State, and she's actually here for an interview with TMSN. And she's going to talk to us a bit about the work that she's been doing during her PhD. Susan, over to you.
Thank you, Ryan. As you said, I just finished the requirements for my PhD at Portland State. And the work I'm going to be talking about is part of the work that I did for my PhD. First, I'd like to acknowledge the team of people who are involved in this. Dr. Delcom was my PhD advisor. Marianne Luca-Nielsen was a key collaborator in Denmark. This work was done in the context of an international digital government grant, and our government partner was SkඇNHD, the Danish e-health portal in Denmark. Tim Toll helped us with modeling and understanding some documents from the Forest Service, and Drs. Vesta and Rubach are physicians in Denmark who helped us with some aspects of the searching study I'll tell you about. And then Dr. Clearbo Jarvelin collaborated with us to develop a session-based searching metric. As I said, SkඇNHD is the e-health portal in Denmark. It provides information about health and the healthcare system to both citizens and healthcare professionals in Denmark, and they've been in operation since 2001. So imagine you're this physician. You're seeing a patient who's about to urgently return to Cambodia. And Cambodia happens to be one of the countries in the world that still has a problem with polio. And so he should have a vaccination, but many vaccinations are contraindicated in the presence of a current illness. So when the physician returns to an online information system, she doesn't want overview documents about polio. She needs information to help her decide whether to give the vaccination today. So if we do a Google search with polio prevention respiratory illness, we get documents about polio. We get documents about non-polio enteroviruses that cause respiratory infections. We get information about polio causing symptoms of a respiratory illness. But none of the top 10 results have the information needed for this physician to make a decision. And we have similar problems with live search until we get to this document at the bottom of the screen. And if we take a look at that document, we'll see an example of a document that does have the information that's needed for this scenario. It's a document about polio that has information about respiratory illness in the context of preventing polio. So the problem is that information retrieval systems typically match the words in queries to the words in documents. But what we really want is to match the information need with all its complexities and nuances to the semantic content of documents. So this is an illustration of the basic idea. The colored labels on the right represent important types of information that you might find in a document about a disease. And the text that's highlighted in the corresponding color is an instance of that kind of information in this document. So the research that I've been doing is about this idea called semantic components, where the labels represent the kinds of information that you might be interested in, and the highlighted text is an instance of that type of information. And a searcher can say that they not only want a document about a particular topic, such as polio, but that you're interested in having documents that contain information about a particular aspect, a particular semantic component, such as prevention. and even specify that you'd like particular query terms to appear in that text. And while it would be nice to improve searching for all topics in all settings, in this work we focused on supporting domain experts when they're using domain-specific digital libraries to satisfy specific information needs. Experts tend to know the types of documents that are available and the kinds of information that they contain in their domain of expertise. And digital libraries tend to contain somewhat more homogeneous collections of documents, presenting a more tractable problem than, say, the entire web. They also present some interesting challenges because those documents often lack the rich link structure that's exploited so successfully by general search engines. And then finally, we're interested in specific information needs like the one I showed you in the scenario at the beginning, as opposed to requests for information just about a topic. So the semantic components approach leverages the knowledge of domain experts and also the characteristics of a given document collection. It represents document content and search requests using domain-specific components of documents, and also representing the types of documents and the types of information in the collection. And these information types may or may not correspond to structural elements in documents, and most likely represent only a subset of a given domain. So our strategy is to provide supplemental indexing that can be combined with traditional indexing, such as full text and keyword indexing, and also allow searchers to provide greater specification of their search that can be applied to subdocuments as well as whole documents. The semantic components model has two main elements, document classes and semantic components, where a document class is a grouping of documents, such as, say, by the type of the topic or the purpose of the document. So in a collection of medical documents, you might see classes of documents about a disease, about a drug, about a clinical method, and then the set of semantic components that's associated with each document class is going to be different for each class. So for example, documents about diseases tend to contain information about treatment, about evaluating patients with that problem, and maybe about referral, whereas documents about drugs have different components. A semantic component instance is the segments of text within a document that contain information about that semantic component. And these can be variable in length. They can be overlapping because a given piece of text might have information about more than one aspect. And they can also be nested inside other semantic component instances. A semantic component schema is just the set of document classes and semantic components for a given collection. And this is an example of a schema. This is the schema that we used in a searching study I'm going to tell you about. And it was in Denmark, so this is the English version translated from Danish. We looked at two ways of developing schemas. The first is a bottom-up approach. We took random samples from a document collection and read each document, outlined the information content, and then using those outlines, developed document classes and constructed sets of semantic components for each class. The other way we looked at is a top-down method. We looked at documents that are mandated by the National Environmental Protection Act. And there are a number of guidelines and templates available for preparing these documents. This is an example of an online template for developing an environmental analysis document that I'm just showing excerpts of it. And when we looked at examples of these kinds of documents on the web, we found that they didn't all follow this template exactly, but they did contain the same kinds of information because they're mandated by law. And they often contain the same or similar boilerplate text. And we worked with our consultant from the Forest Service, Dr. Toll, who helped us understand what of these kinds of information would actually be useful to land managers who are searching for these documents. So not all of them would necessarily be of interest for searching. So I'm going to tell you about the two main studies that we did, the two main user studies, a searching study and an indexing study. But before I do that, I was going to give you a better idea of what I mean by semantic component indexing with a demo that requires an internet connection that I don't have. So, so I'm going to show you screenshots instead. So this is a document that we used in our indexing study. It's in Danish. So I'll just tell you that it's about total hip replacement operations. And I picked a really short one so it would fit on the screen. And to index this document, you would first use the little radio buttons on the right to select a document class. And then the next step, the application brings up a set of window panes on the right, one for each semantic component associated with that class. And let's see if I can get this to work. The way you use this.
The previous slide, you had this document class.
Mm-hmm.
Really just 3 document classes that cover everything? How did you come up with it?
So for the indexing study, we wanted to keep it simple, and we only had 12 documents that each indexer, this was done manually, and so we wanted to just look at 3 classes so that we could have multiple examples in each class. So no, this isn't a complete description of all 24,000 documents in the collection. Good question. Let's see. So to use this application, you just highlight with the mouse, right-click, and then it brings up this menu here of the semantic components for that class. And then you just select off the menu, and it automatically copies the text into the pane and color codes it so that you can keep track of what you've already done. And if you change your mind about something, there's a button to basically erase the indexing for that component so that you can repeat that part.
What if something overlaps 2 categories?
So if it overlaps, the same text will appear in 2 windows. And the one thing I didn't do with the interface was to try to blend the colors. This is just a prototype, and that seemed like maybe not the best use of my time. OK, so that was the demo that's not live. And I'll just go back to the slides. So what I'm going to do next is tell you about an interactive searching study. So our research addressed the following questions. Does the use of semantic components facilitate more successful searching? Does it facilitate faster searching? And does it result in better document ranking? So we built an experimental search system working with SharePoint. And we copied all 24,000 plus documents in their operational system into our test system and built the search engine on top of UltraSeek, which is the commercial search engine that they use. And then we built 2 interfaces to the underlying search engine. I should say when we copied these documents, SharePoint uses both full text indexing and manual keyword indexing of their documents. So we copied all of the text plus the metadata fields that contain the keyword indexing. System 1 is a mimic of the operational system. And System 2 has the same things as System 1 plus some additional searching features. And as I said, both of them operate over the same underlying documents and search engine. And in addition, we didn't have enough resources to manually index almost 25,000 documents. So we indexed a subset. And that information is recorded in metadata fields for the documents that were indexed. This is the interface for System 1. And you'll see there's just a simple search box that is the same as the simple search box in the operational system. And then 2 filters that we took from the advanced search interface. This one allows the searcher to limit documents to a particular information type, where this is a classification system that's used by SharePoint. So this isn't our semantic components. And the second one is a filter for selecting only documents applicable to a given region in Denmark, which is important because of the way the healthcare system is organized. System 2 has the same simple search box and filters. And in addition, it allows the user to enter search terms into boxes associated with different parts of the schema. So this example, the searcher is looking for documents about asthma, and they would prefer to have documents of the clinical problem class that contain a word form for the Danish word for pregnancy in the treatment semantic components. And this asterisk is a wildcard that'll match any characters at the end of the word. This is a schematic of the retrieval. You have a question?
The character, the wildcard important because Danish has complicated morphology. Is that another reason for it?
Well, it does. You know, English has the same sort of thing. So this would match the equivalent of pregnant, pregnancy, pregnancies. But Danish does have a lot of compound words that makes certain things more interesting.
So is this really a two-level classification?
It's a two-level hierarchy. So there are classes, and then each class has semantic components, although some of them have the same names. And one of the things that one of our ideas was that if we reuse names where possible, where the meaning was similar, that would provide less cognitive load on the searcher. I'm not sure, actually, that was the right thing to do. But it turns out that the schema itself is a lot more important than we anticipated in terms of getting it right, because although we provided the searching subjects with a fairly complete description of what we meant by each label, they only looked at the labels. So this is a schematic of the results retrieval, and I'm going to walk through each system separately. So for system 1, the user can enter a topical query in the simple search box and optionally enter values for one or both filters. System 1 takes that query, sends it to UltraSeek, which then returns a web page with a ranked list of search results based on the topical query and restricted by the filters. System 2, the user again can enter the topical query, filters if any, and as I showed you, they can also enter terms optionally in those boxes for the semantic components. So we called that the semantic component query. System 2 sends first just the topical query, the values for filters if any, to UltraSeek, which then returns again a ranked hit list. But System 2 intercepts that list and then sends a second query if there are any terms in the semantic component boxes, and intercepts the results of the second query. So this is just searching the metadata fields that contain the semantic component information or text. And then System 2 uses the results of the second query to re-rank documents in the first query. So it's not adding any new documents, it's just potentially re-ranking them. And then returns a web page with the results. The results display for System 1 is identical to the operational system. So there's a document title, an UltraSeek generated snippet, and an author generated summary. System 2 has the same elements, but in addition displays the document class and a list of semantic components present in that document. And these numbers are an indication of the size of the text. It's the count of how many characters are in that text. And the idea is that it could help a searcher decide which documents to click on. This shows you the organization of the user study. We had 30 experienced physicians participate. And we studied each one separately in a 2-hour block over 5 consecutive days. And each block started with an introduction to the study and to semantic components, followed by some training. that included guided practice with the two interfaces. And then they each worked through 4 scenarios, half with System 1, half with System 2. And the order in which they used the systems and saw the scenarios was randomized. This is a summary of the 4 scenarios. And what you'll notice is that each one is a problem in the context of an individual patient. And there's a certain amount of clinical knowledge required to translate from the information in a document to applying it to this particular patient. We made relevance judgments on a 4-point graded scale, from 0 for non-relevant documents to 3 for highly relevant. We had the searchers rate all the documents that they actually clicked on and looked at. We also had a separate set of relevance judgments by a domain expert. This is Dr. Vesta, who's a family practice physician and a researcher at the medical school in Aarhus. And so he made relevance judgments on all the documents that we found during the design and refinement of these scenarios, plus any document that was rated at least marginally relevant by 1 or more study subjects. Our evaluation strategy was to look at 2 pairs of perspectives. There's a system perspective and a user perspective, and also a single query perspective and a session-based perspective. So from the systems perspective, the goal is to return documents in ideal order, meaning that you return the most highly relevant documents first. And for the system perspective, we used the reference standard of relevance judgments. So these are the ones by Dr. Vesta. And the user's not completely out of the loop because the documents are all retrieved in response to the queries from each of the 30 searchers. Now, from the user perspective, the goal is to satisfy the information need. So from this perspective, we based relevance on individual searchers' opinions. And note that if the searcher didn't click on a particular document, that's an implicit judgment that this document is not relevant. Traditional IR metrics reflect a measure of goodness for a search result for a single query, usually a ranked list. And the overall score is an aggregate for some number of information needs. And typically there's 1 query per information need, which makes it very convenient, but also unrealistic. Because in real life, searchers often end up reformulating their query. If they don't find what they need from the first query, they'll typically enter another query. And so what you have is actually a sequence of queries. So this is a summary of our evaluation strategy. And I'm only going to talk about the results from the system perspective. But if there are questions afterwards, I can also talk about the results of the user perspective. So we were interested in knowing, will semantic components enhance searching given a good query? So for each search session, we defined a best query. And because we instructed the searchers to search as they would in real life, so search until they either found an answer or would give up given the constraints of a clinical setting, typically the best query was the last query. So from the single query perspective, we used 2 different metrics to define the best query: average precision and discounted cumulative gain. From the session-based perspective, so I'm going to talk about this session-based metric where we discounted the results from progressive queries in a sequence. And so we looked at the session-based discounted cumulative gain of the best query and also looked at concatenating results over a series of queries. And I'll talk about that in a minute. We also used this best query approach from the user perspective. Typically, the users identified one highly relevant document. So we defined the best document as being the first highly relevant document that the user found and identified, because occasionally they'd find more than one in the same query. So we looked at the reciprocal rank and the discounted gain of the best document. And then we also looked at a number of other indicators of a search session, including a session-based version of discounted gain for the best document. So this is the result for the best query in each session from the system perspective. So using the reference standard of relevance judgments. So in this case, there might be multiple relevant documents in a given query. And what you'll notice is that for both metrics, System 2 consistently outperforms System 1. And when we aggregate all of the scenarios, these differences are statistically significant. Now, the scenarios were also significantly different, which we expected because we wanted to have scenarios of differing difficulty. And there was no interaction between scenario and system using a two-way analysis of variance.
How many documents were indexed?
371.
And how big were the test sets for these experiments?
There were, what was it, over 24,000 documents total being accessed. And we set a limit to return up to 100 documents per query. Although because they used the filters, often the results list was shorter than 100. So I'm sure you're wondering, well, how did you choose those documents that you indexed? And we tried to identify in advance all the documents that might be returned by the queries that they might ask. And those are the ones that we indexed. And we did a retrospective analysis that I can go into at the end during questions to try to show that the selection of documents to be indexed did not bias the results of the study. So we managed to index all of the relevant documents in the reference standard, plus a large number of all of the documents that were returned early in the search results.
So for each of the scenarios, there's a guaranteed good result in your selection?
There was a different number of relevant documents for each scenario. Well, yes and no. So for 3 of the scenarios, clearly the answer was yes. For scenario B, there was only one document that our expert user deemed as being highly relevant. And there was disagreement among the searchers, those who actually looked at it. I think it was about half agreed that it was highly relevant, and the other half disagreed. And it had to do with the stage of a woman's pregnancy, how many weeks she was pregnant in the scenario versus the coverage of the document. So we also, I'm not showing it here, but we also analyzed the results without scenario B. And it doesn't affect the overall result. But
you weren't looking, I'm sure, at differences across users, but my guess is there would be. Were some users noticeably better at all scenarios?
Yes. There was one user that, I don't know if it was only one query for each session, but it was only one for, I think, 3 of the sessions at least. And one user who was, I would say, not as good as the others. We haven't actually analyzed the data statistically from a user point of view, but Dr. Nielsen, who's an information scientist, is interested in getting at some of the data more qualitatively. And so she's looking at how can you describe the best queries? What is it about queries that made them good? And she's also interested in this idea of searchers being, better than others, and what were their strategies.
Is there a difference in motivation? That is, would most of the doctors consider this kind of searching to be part of their core job, or is this something that they rarely do and that they're just supposed to know the answers or not?
No, most of them did feel like this was an important task that they do. And in talking to them during the training session, many of them expressed frustration at not being able to find documents quickly. I think it would be rare now to find physicians who actually believe they know everything or should know everything. The interesting thing about this group of searchers is they were all highly experienced physicians. These were not medical students or residents, which is what you would do in this country. I don't think you could do this study in the US because you wouldn't get these experienced physicians to come participate.
I was going to ask about the difference between the healthcare system in Denmark and the US, because my personal experience is, yes, my primary care physician doesn't consider himself an expert on everything, but rather than go look up the answer to the question, he'll refer me to an expensive specialist who I had the experience once of being, he saw, my primary care physician saw something on one of my tests that he didn't know what it, and referred me to an expensive specialist. I spent like 2 minutes with the specialist. He looked at the result and said, "Oh, this is not significant. Go away."
Right, right.
Yeah, but in terms of the total cost of the healthcare system, if my primary care physician had looked up the answer to the question, it would have saved money.
Right, right. The healthcare system is very different. And that was one of the really fun things about doing this research is, well, not only did I go to Denmark 4 times, but I learned a lot about the culture in the healthcare system. And it's socialized, so it's all heavily subsidized by the government. And the primary care physician there has a very strong gatekeeper role, much stronger actually than in this country. And one of their really important things to them is that in order to refer a patient to a specialist, they have to jump through some hoops. So they have to know exactly what information needs to be sent with the patient and what the criteria are for the referral to be accepted. And so one of the really important information needs for them is to find these referral guidelines. And they vary by region, and that's why the regional filter is so important.
So they have to do this kind of searching in order to be able to make a referral.
Right. So they either do it online or they do it on paper. And more they're going to online. And so these physicians were also experienced searchers, both on the general internet, and most of them had used SharePoint quite a bit. So this organization is interesting. I'm not sure exactly how it's funded, but it's a government or quasi-government agency, and it's really important to them to serve the physicians, to provide them with this information as well as the citizens. And then there's another part of SharePoint that we didn't deal with, which is electronic healthcare, individual patient data that's electronic and they can access. But we didn't get into any individual patient data. Any more questions, or should I go on? Okay. Sure.
Maybe we'll talk about something interrupting just the case. But have you tried to look at the queries and take the queries from the advanced system and actually send them to the regular system just by appending the words from the advanced queries, from the advanced boxes to the original query to see what kind of results you get? Because this is a bit of an unfair, right, comparison right now.
Well, so what we did was to try to mimic the system and the, oh, so you mean the from the semantic component boxes?
Yeah, you just take those words and append them to the original query and see how the results change and if you get better MDCG. Because if you get, then it's just the fact that the person felt compelled to give more information to the search engine, which is very different from what we were taught by Google and the other search engines, where it's better to send shorter queries.
Right. So we haven't done that. I mean, one of the things that we wanted to find out is using this technique, can the users make use of it? Can they figure out how to express their queries and give us this additional information? So they had a choice of whether or not to put anything in those boxes, and they didn't always use it. I think either all or at least 20, I think all of them used it at least once, but many of them didn't use it as their first choice even when they had System 2. If they thought they could get there faster with just a simple query, they did. So we analyzed the data from what in medicine is called an intention to treat perspective, which is you treat them as using System 2, whether they chose to use the features of it or not. So it's by giving them this, did it help their searching? Which perhaps underestimates the effect, but it's analogous to in medicine. If you give somebody a medication, then what you really want to know is does it help them that you've given it to them, because they may choose not to take it. And you can bias your results if you only look at people who actually took it, because then you don't know how many people didn't use it because of side effects, or in this case, because they didn't want to take time to type into the boxes.
True, but this actually shows that we are biased towards one box short query, right?
Mm-hmm.
And it's hard to break out from that paradigm.
Right.
That's why I'm saying, what if you just appended those, pretending that they would append
Mm-hmm.
them themselves and they weren't biased by that short query model, and see maybe the results are the same then. I don't know. Hopefully
Right.
not.
No, I think that's an interesting point, and it's worth looking at.
So yeah, I think what you're asking is, was it the interface or was it the search engine? Because you could have used the same interface and then just stuck the things on the query and used the old search engine.
But we are biased, right?
Yeah,
I mean,
but no, I think
it's
it's a great question. There's two main factors here. One is the different search engine, and one is the different interface. And it's hard to say where the effect comes from.
That's true. And we don't know if that's the best way to capture this information from them. I mean, maybe you could automatically analyze queries and say, oh, this person is asking about treatment. But then you have to figure out, which part is sort of the main topic and which part is the part specific to the treatment.
I just think I must be missing something about how you're handling bias in these experiments, because from what I understand, you've taken the documents that you think answer the queries that will be asked, you've added semantic components to them, and then if people use semantic components, they're going to be pulling out documents that you already know will be the right ones for those queries. How are you correcting this?
So what we tried to do was to figure out in advance what are all the documents that are going to compete with the relevant documents. So what are all the documents that might contain the terms that would be in queries but aren't relevant? And the reason that this worked was that, first of all, we didn't add any new documents. We were just re-ranking. And second, that a very, very small number of documents were actually relevant. And so maybe at the end I'll show you some slides that show the analysis that we did, where we looked at the ratio of documents that were returned that had been indexed and that were or were not relevant. Because that was our biggest concern, is how can we do this study when we can't index all of the documents? And I think we have convincing evidence that, in fact, we managed to predict enough of the documents that competed for ranking that weren't relevant that it actually didn't bias the results. But that's a really good question. So this graphs the mean NDCG for the best queries in each session. So what I showed you in the table before is just the final cumulated gain out to up to 100 documents. And this shows that the reason that the end cumulative gain for System 2 is higher than System 1 is primarily because it returned highly relevant documents very early in the results. And this little dip is just characteristic of normalizing for scenarios with different numbers of relevance judgments, and I can go into that later if you want. So this discounted cumulative gain, maybe you're all familiar with this, where the idea is that a higher ranked document appearing early in the list is worth more to you as a searcher than one appearing later in the list. And so the original DCG calculation discounts documents based on the rank at which they're returned. And the original formulation uses this logarithmic function to discount documents only if they appear after a certain threshold. And the threshold is the base of the logarithm. And it's actually a little bit clumsy and has this sort of sudden threshold. And when we were looking at a session-based metric that's based on DCG, I suggested, well, if we just add 1 to the log, then we don't have to worry about that threshold, because we won't have to worry about dividing by a number that's less than 1. And so we ended up using this idea for DCG as well as SDCG. And because that came after I'd done the first analysis of the results, I can tell you that they don't change whether you use this equation or this equation. But in the recent paper about the session-based, it's actually using this new way of calculating DCG. So what is the session-based metric? So the idea here is that not only are documents returned later on a list of somewhat less value to you, but also documents returned at the same rank on a later query are of less value, because you'd rather get them in the first query. So the idea is that we discount documents not only by rank, but also by the query iteration number. So for, say, a given query, or a given document rank in a given query, we use DCG to discount by rank and then do a further discounting by query iteration.
What is the queue there?
So
To me, this is, you're changing the query, and the final query could be completely unrelated to your initial query. And
right.
This is.
So the idea is that you want to look at a search session in a sort of holistic fashion. So the user enters a query. Maybe they don't find what they were looking for, so they reformulate in a second query. And you might get a completely different result. And then maybe they enter a third query. And so if they're only finding what they're looking for after 3, 4, 10 queries, you shouldn't give as much credit to your search engine as if you gave them that a relevant document in the first query.
So you're hanging this on the intent rather than the query, on the information need or whatever.
Right. So, so it's the results of the query, but it also takes into account how long it took you to get to that query. Does that make sense? Okay.
Why did you choose? Sorry.
Well, I was just wondering, did you observe cases where document X comes back, say, in third position for query 1, and same document X comes back in second position on query 3, and only then does the user look at document?
Yes. Yes. That was actually one of the most interesting things to me in looking at the query logs. They would often skip over a document that in the reference standard was highly relevant, and that all the other users who looked at that document thought was highly relevant. And they would completely skip over it and maybe click on some other document lower on the list. And that document might appear again in a later query, and they might or might not click on it. But sometimes they would click on it in a later query and say, oh yes, that's what I was looking for. And so this phenomenon of missed documents is really interesting. And we know from talking to the searchers that in some cases they were familiar with using this portal enough that they were looking for a particular document. And so we're thinking that maybe they didn't notice these relevant documents because they had a fixed idea of what they were looking for. So in some cases it was more of a known item search. And we don't know how often that was because we didn't find this phenomenon until later. And I'm dying to do some work to figure out why users miss documents.
When you chose log of queue, is there some, I mean, it seems to me that it's not necessarily clear to me that going 20 queries is only half It's not much, not a whole lot worse than going, I don't know, 19. Every extra query seemed almost linear to me. It's actually a little bit worse.
Yeah, so it's hard to know how to set the knobs on this. This was developed with Dr. Garveline, who did the initial DCG, and his feeling there was that the logarithmic discounting was just a nice, seemed appropriate. And by setting the base of the logarithm, you can model either a more impatient user or a more patient user. And so we followed the same general line of thinking for the session-based discounting. And the interesting thing about it is because there aren't any equivalent metrics, it's hard to say, is this the right way to do it? Is this the best way to do it? And we're interested in getting more user data to figure out how should you set these knobs.
How would you decide that?
And well, one thing would be if you had, say, eye tracking data. So if you knew exactly how far down a user tends to look before they click to the next page, that might give you some idea. Are they more likely to just look deeper in an original list, which suggests that first list is more valuable than a second query? Or do they just look at a few at the top, maybe just the first screenful, and then if they don't like what they see, do another query? And in which case, then maybe you want to discount by rank more than by query.
It doesn't model how annoyed they are having to enter the queries.
Right. And so, this is in the very early stage of this idea. It was just published a few weeks ago. It was presented at ECIR. And I understand there were a number of questions about exactly that. How would you set the knobs? And in some cases, depending on how you set the knobs, you might get more accumulated value from documents appearing, sort of unusual ranks in comparison to each other.
What did you choose for PQ and why?
So for this study, we used a log base of 2 for both the rank discount and the session-based discount. The idea being that we're looking at a clinical setting that's very time constrained. And so we expect these users to be very impatient. And so we did fairly steep discounting in both cases.
Do you believe that you could reject the null hypothesis and say that one system's better than another pretty much under any knob setting?
You mean based on one setting? Could you generalize that to others? Or?
Does this knob setting change the results of your study?
That's a really interesting question. And it's something we haven't done yet, is to look at the whole range. And actually, when I show you the results, what this session discounting did was to show that although the SDCG was higher for System 2 than System 1, it's not statistically significant anymore. Because what we found out was that although System 2 returned relevant results overall higher in a result list, it took these users more queries to get there. And whether that would go away with having experience with using this technique, we don't know.
You might wonder if the query is the right unit. It might be like how many characters they type for something, because you have to type more information into your system as well.
Right.
So you might model how much work did the user do to get to the result, which includes sort of these eye tracking things and the typing.
Mm-hmm. And we also
time is just the right
measure. Yeah, and we looked at time, and in fact, it took them a little bit longer overall using System 2 than System 1. On the other hand, they had fewer unsuccessful search sessions where they just gave up.
Those are infinities, though.
Right, but in this setting, where we told them to simulate a clinical setting, they gave up earlier using System 1 than System 2. So they had more successful search sessions with System 2. So there's a lot of different pieces of evidence that make this interesting to me.
So I can see that just for a single query, log or log-based or whatever is not going to make that much difference, because everything you still are saying this is more relevant, by order. But with this the second thing, the session-based, if you choose log BQ in different ways, you're actually going to interleave the results in terms of how relevant you're saying they should be. And that seems to be a much more sensitive, you know, sort of slippier ice to be working on than the original. I don't know exactly.
I think there's a lot of interesting work to be done with this idea of session-based metrics. I mean, this was kind of just our first cut at it, and we're talking about all the different ways that we could kind of look at the behavior of this metric and some variations on it. So I haven't gotten to it yet, but the other thing that we did was to look at taking the first, and again, this is an arbitrary number, taking the first 10 results from each query and stacking them on each other and looking at SDCG. And so one of the questions that arises there is, what do you do with duplicate documents? Say if they're relevant, do you count them the same each time they appear? And in this study we did, largely because of this missed document phenomenon where they sometimes found it on a later query. And so it was obviously of value to have it come back a second time. But in, you know, if you're studying a different question in a different setting, you might make a different decision there. And the results that I'll show you, you know, just take the SDCG for each 10 and stack them on each other. But another idea that came up at ECIR and that we're talking about looking into is just stacking all the results as if they appeared in one long list and then just doing rank discounting and comparing that to this. And
This strategy doesn't account for, again, our model of using search, I think, and I mean, these were the questions then, but I just want to emphasize, I mean, the problem here is time. And you said that there are users that were skipping a document and they were clicking on it in the next iteration. So, but that was because of, it could be because of reinforcement. I saw the document one, I said, oh, maybe it's not relevant. I see it again for next query, I say, oh, maybe it is relevant. Right? And it was because I saw it first there. So this doesn't account in any way for that model. So the discounting has to be with time because I think a lot of users value time more than anything. So I would send 20 queries if I can just scan the results and pick up them. And I'm much happier with that than deep thinking, how should I formulate that query?
Yeah. But then you also have to figure out, well, how do you account for the time that the user spends? You know, say they do click, you know, some users click on more documents than others. They have a lower threshold for, oh, I think I'll look at this and see if it's any good. Or they spend more time looking at the document before they reject it.
Time to the click on the one you want or whatever from the beginning of your session to your information satisfied, or until you see the document, in terms of DCG, until you see the relevant documents. You know, that's how much time it takes. But it takes you 10 minutes to write your next query, then that's a lot different than if it took you 10 seconds. So
right.
It seems like number of queries might just be the wrong.
Yeah, and that would account for the fact that users have different models, right? Because now you're counting with the same measure, time, rather than, well, one user spent 5 minutes looking at the documents on the first page, then he looked at the second page, and then the third page, and now you say the second page for this user is the same as the second page for a user that just jumped to the next query, and that's not true.
Right. I think interactive search is a really complicated thing, and I think, time is one way to look at it, but I think we can get a lot of information about how people search and how they respond to results lists by looking at things from a lot of different perspectives and a lot of different metrics, and that's kind of what we're trying to do here. So. Right, and we do have the measurement for time.
Can I just ask how much more you have to go, because we're getting kind of bogged down here.
Okay.
Sure.
Okay, I'll move on, and some of this we've already talked about. So this is the session-based results. So as I said, system 2 still has a higher mean SDCG, but it's not statistically significant anymore. And this shows the shape of the curve, again, plotting from document rank 1 out to 100. So the table just had the final result. And again, you can see that the difference is related to this early return of relevant documents. This is plotting what I was talking about of concatenating the documents in groups of 10. and 10 was just arbitrary based on knowledge that many users don't look beyond the first page and that most search engines return 10 pages or 10 links per page. And as I said, we did a number of other analyses, and I have all this stuff in slides I could talk about later, but I wasn't going to get into this right now. This analysis of the effect of partial indexing is obviously really important and came up earlier. And the short answer, we believe, is no, it didn't bias the results. So I'm going to talk about indexing a little bit. And we wanted to know, is this feasible? And how does it compare to keyword indexing with respect to time, effort, and quality? And we're comparing it to keyword indexing because, although most of us have this idea that web search is all there is, in fact, in this portal, there's very little interlinking of documents. And to try to get better search results, SGÇÖ has invested a lot of human effort into doing manual keyword indexing. And originally, that's what they wanted us to work on, but we discovered that the controlled vocabularies they were using actually didn't fit their documents very well, and their indexing was all over the map. So just a reminder of what I mean by semantic component indexing. This is a Forest Service document marked up, it's actually a decision notice marked up by Dr. Toll. So we had 16 indexers who do keyword indexing for SGÇÖ. We gave them 12 documents with the idea that they would do half using each method. And again, we looked at time. We also looked at their perception of how difficult a task this is. And we collected the data on paper because we wanted to avoid user interface issues. So this shows the time. And semantic component indexing took a little longer. It was a brand new task for them. But you can see that it's in the same ballpark with the same kind of distribution. Now for the searching study, which we actually did later, we had 7 people from this original group who indexed documents for us, and they used the the application that I was demoing earlier. So you can see it's actually a lot faster, that most of the documents took under 5 minutes, and many of them were less than 2 minutes. And the difference might be from the application. It might be because they were a lot more experienced at that point, and they were also self-selected. The people who volunteered to help with this were probably the ones that were most comfortable with the idea to begin with. This summarizes a lot of data from the questionnaire. And basically what we were getting at is how difficult are the different subtasks involved in keyword and semantic component indexing. And I think what this shows is that for the most part, they didn't find any of them to be very difficult. And there's not a lot of difference between the different types of indexing. Most of the responses were in the medium to somewhat easy range. So that was sort of the easy part. The hard part is how do you compare indexing instances between users? Because we were interested in consistency. And this is a photograph of 2 documents indexed by different people. Same document. And it's a little hard to read, but what you see is, this person marked this paragraph. This one didn't include it in any semantic component. They're the same in these lower 2 paragraphs. The ones in the middle, this person has a nested semantic component instance. This has 3 separate ones. This is a little easier to read. This is the same highly condensed document repeated 4 times with different hypothetical indexing. And if we focus on, so the color of the font indicates that this is labeled with the label in the same color. If we focus on the word frequency, we can see that they've been marked with the same label, but differing amounts of text have been marked. So this suggests that, well, what we want to do is compare the boundaries, the extent of the marked text. But if we look at numbers 2 and 3 and focus on the word age, they've been marked with different labels. Not only that, but the text associated with the label has a different extent. So now how do we compare them? And in the 4th one, this purple font represents the fact that this person has included those sentences in both semantic component instances. So now what do we do? And So I'm going to take a step aside and talk about how to do this indexing evaluation and then come back to the indexing study. So we wanted to look at consistency, by which we meant the agreement among indexers, accuracy, meaning how does it compare to a single reference standard for a given indexer. And we wanted to evaluate 3 subtasks. So assigning a document class, indicating the text that comprises a semantic component instance, and then of course the label for that semantic component instance. And I'm not going to go through all the gory details. We looked at a lot of different related tasks and the metrics that are used in that work. And our final approach was to consider indexing as a categorization task. So for document class, that's pretty easy. But for semantic components, we decided that we could treat each text unit as an instance of multiple categorization, where it could, because it can belong to more than one semantic component instance, or none, we can treat it as multiple binary classifications. And that allows us to look at each semantic component instance independently, which is handy because that's our basic unit of interest in this study for retrieval and ranking. And so for a given semantic component, we can compare the units that are in the component. So that becomes equivalent to comparing boundaries. So again, I have a matrix here of our evaluation approach. And I'm only going to talk about semantic component indexing, but we also looked at how to do evaluations of keyword indexing. And what we came up with was for accuracy that we could calculate recall and precision on a character basis for the semantic component indexing. Or you could also use words. We happen to use characters. For consistency, we used a metric called Krippendorff's alpha. Has anybody in here ever encountered Krippendorff's alpha? Okay. So there's a nominal version that we use for document class and a binary version that we used for agreement on inclusion or exclusion of characters. And Krippendorff's alpha is a family of metrics for consistency that can handle various types of data. And all of them account for the probability of agreement by chance. And they're all based on the same general formulation where you're comparing either, you can couch this either as agreement or disagreement. But looking at, say, observed disagreement, which is what you see in the data, compared to expected disagreement, which is what you would expect to see if it's done entirely on a random basis. And this derives from the content analysis literature, and it's used primarily in the social sciences. And so what they're doing is assigning codes to data. And in some cases, the unitization has already been done. So maybe you're coding a sentence or a phrase or a paragraph. But in other cases, the analyst has to decide what part of a document the code applies to. And this is called unitization. And so there's this version of Krippendorff's alpha that is for unitized data that takes into account the boundaries of these different units. And the idea is that, well, applying it to semantic components, each semantic component instance, each segment is a unit, and they can be separated by gaps. And so each unit has a starting position and a length. And you calculate disagreement based on the sum of pairwise differences between units and gaps, considering all possible pairs. So as the amount of overlap decreases, disagreement increases. So that makes sense. This looked like a really good model. Now, where all of these metrics get tricky is how do you calculate expected disagreement? So what's your model for what would happen if it's done randomly? And the way this metric does it is it tries to compare all possible ways that a document could be unitized. And it gets really hairy. And I ended up doing this really extensive analysis of the behavior. And it turns out, at least for semantic components, that indexing instances that should be logically equivalent end up with different values for Krippendorff's alpha. So if you take a document and you just permute the order of things so that, say, you change the order of paragraphs, but you don't change the indexing at all, you end up with different values. And it's because of the way the expected disagreement is calculated. So this looked like a really good idea. It didn't work. So that's why we did the fallback to treating it on a character by character basis. So coming back to the indexing study, this is just one of the analyses we did. This is by semantic component. And what you see is that some of these semantic components were easier to index than others. And we looked at both micro-averaging and macro-averaging, which I don't know if everyone here is familiar with it, but they're just different ways of looking at aggregates of data. And this is the consistency data. And again, some semantic components were more consistently indexed than others. This is what was really interesting. This was all over the map. And it turns out that this particular semantic component didn't arise from our original bottom-up analysis of the collection. So it was done kind of at the last minute, right before the study, based on a much smaller sampling of data. And one of the things that came out of this analysis is that this is actually a nice way to determine whether you have a good schema or not. Because if indexers can't use it consistently, probably searchers can't either, and it's not going to do you any good. Okay, I'm going to wrap up. And so we think semantic components can enhance retrieval by improving document ranking. The really interesting thing is that improved document ranking did not result in a significant improvement in search perspective, in search performance from the user perspective. And I didn't go into all the results here, but this echoes some findings in other IR studies where people have looked at giving a known better system to the user for a task, and their task performance is not any better, even though the search engine performance based on like test collection data is better. And we also found that manual semantic component indexing took slightly longer than manual keyword indexing. The perceived difficulty is similar. And I didn't show you the results of the keyword indexing consistency data, but it was all over the map. Most of it was often not much better than random. And so we can't actually directly compare semantic component indexing to keyword indexing because it's different metrics, different units of measurement. But our sort of anecdotal impression from how bad the keyword indexing was is that semantic component indexing is likely to be more consistent and more accurate. We think the session-based metric is useful for evaluating interactive searching result. And we may not have the right metric yet, but I think we're looking in the right direction. And as I said, calculating agreement between indexing instances is challenging. And this unitized version of Krippendorff's alpha exhibited unexpected and unwanted behavior. Obviously, what I've shown you here has lots of limitations. We have some preliminary evidence, but there's a lot of additional work that would be needed to be done as far as generalizing this. There are a lot of variations you can do on the semantic component model. So for the studies I showed you, we only allowed one schema for the document collection during the study, and only a maximum of one indexing instance per document. But we encountered a number of examples of why loosening those restrictions might be useful. And so we'd like to look at what happens if you allow multiple schemas per collection, say for different user groups. And there's some variations on this two-level hierarchy that might be useful. Here's the big bugaboo. So how do you increase scalability of this approach? And the two main approaches are, first of all, doing end-user indexing. A lot of the time and effort for manual indexing is just spent reading and understanding the document. If you have a user that's already taken that time, if you can get them to do some indexing right then, it only takes a few minutes to highlight and right-click, then you might be able to collect a bunch of indexing instances and use that as one of your features in ranking documents. So it's the whole social tagging idea, but at a subdocument level, and it's just incrementally added. The other approach, obviously, is to automate this. And trying to replicate human indexing is probably going to be really hard. But I think there might be some coarser ways to do it that you could do automatically and maybe get most of the benefit at a much lower cost. This relatively lacking correlation between better ranking and the user-oriented results is just begging for more study. This phenomenon of missed documents is really interesting. And then, as I said, in trying to evaluate indexing, there's a need for better metrics. So how might we apply this? If you tried to do this on the general web, you're not going to be able to come up with a usable schema that's fixed that users are going to use. Having an open schema, which basically means there's one universal schema that involves everything a user could possibly choose, would be like social tagging. And it might be possible to accumulate incremental end user indexing and then incorporate that data. But I think it's probably more likely to be useful and practical in a more restricted setting, such as a vertical portal. And obviously of interest to me is health search, where you can use domain knowledge to either develop a starting schema that you could use for automated indexing, and that maybe your users could just use, but contribute end user indexing, and maybe you can combine evidence from those two sources. So you get just a little bit more semantics into the search without having a big impact on how users do the search. The other place this might be useful is enterprise searching, where you have a more restricted document collection, maybe more homogeneous, and you have a community of users who might be more motivated to do this, either for themselves or to contribute to a community. And there you might also be able to use existing structure in documents. And then the last place this might be useful is in personal search. So just this idea of subdocument tagging could be useful for refinding, reusing, organizing information. We're almost out of time. This is a list of papers that have already been published. This is the searching study that I talked about. This is just the single query system-oriented evaluation. This is a study I didn't talk about that we did very early on to look at whether you could use this idea of semantic components to express information needs. And so we took an existing taxonomy of clinical questions and mapped those questions. They're expressed as generic questions like, what is the treatment for X? And mapped those to schemas that we developed for appropriate document collections. This introduced the session-based metric, just came out at the end of March. And this is a sort of future tense proposal of trying to use end-user indexing. There's a couple more minor papers and presentations. I want to acknowledge our funding from National Science Foundation, National Library of Medicine. This is an organization in Denmark that provided funding to pay these physicians for their time to come and participate in the searching study. Sunhed Deco provided lots of in-kind help in organizing these studies. Franz Lecour got us a research license to use UltraSeq. And then I certainly need to thank all of the participants in our 2 user studies. Thank you.
So you mentioned live search. Did you check out MedStory or?
So I looked at the health search that's part of live search, and actually I looked at that and a couple of other health-oriented search engines. And I think people are trying to get at this, the different kinds of information that people want. I'd say overall that those don't work as well as they could yet. I I think Live Search is doing a little bit better than another local health search engine that's trying to do this. But I think there's a lot of room in this area because there's so many people that search for health information, and even I have a hard time finding what I'm looking for. And
yeah, we have not done a great job of integration. We bought a company called MedStory last year.
mm-hmm.
Last, well, I mean, 1.5 years ago, something like that. We have we have health.live.com and health.msn.com, which return different things. And if you just put in some very common health terms in search, you'll anyway get some information from that. But I like going back to MedStory and checking out stuff. And they're doing a lot of the things that I'm viewing your work as like faceted search, where you also do the faceting, you do the, what you call the indexing.
Mm-hmm.
They've done a good job, so I'm curious to know if you compared your stuff with theirs.
Yeah, so is MedStory a separate search, or so that's what you get, that's what's underlying the health search? Yeah. Okay, yeah, so I have looked at that.
MedStory plus something more that have to be acquired.
I see.
Yeah. MedStory exists still as a separate website, so you can try that out there.
Okay, yeah, I haven't looked at their separate site. I have looked at the health search that's part of Live Search.
I think they took components of MedStory and put it in here.
Yeah.
It's really, it's a nice site. I like it.
It is a nice site, actually. I was impressed with how it works. And in fact, actually, I had looked at MSN search when I was teaching an IR course a little over a year ago, and I have to say I wasn't overly impressed. But in looking at Live Search now, it is so much better than MSN was a year ago. I was actually quite impressed with the improvement.
Remember, you're being recorded.
Oh dear. Yeah.
Okay.